ASM chats. We will continue our discussion on ASM chats, which are considered to be the alternative for finite state machines. Alternatives for finite state machines. Now, before that, just answer this. Now, suppose Dattatreya. Suppose that can you hear me? All the batches. Right. Now, suppose Dattatreya has cleared entered into final round for Innovate FPGA అనుకుందాం. Innovate FPGA competition 2021-2022. Now, which is scheduled at California. Between May-June 2022. So Dattatreya and his team has written a proposal, and they have qualified for the final round, the grand finals. They have qualified for grand finals. And we all know that to enter into the grand finals, they are supposed to clear the first round, the scrutiny or verification round, the first round. So this is cleared. Then after that, so they have cleared the regional finals also. And in regional finals, there were the top three teams in Asia Pacific Japan region. So top three teams of each region will be entering into the finals. Now, whenever they have cleared the regional finals, so they will be getting a prize money of so and so. Suppose if it is some $100 and count. So $100 plus travel plus traveling expenses plus food and accommodation and plus again in grand finals they will be getting another prize money and the prize money. Now what happened is, so immediately, so as the Dattatreya and his team got selected for the grand finals, so they got approval for the visa approved. First they have applied for passport. It is done. Visa is approved. Then they have booked their flight tickets also. Flight tickets to California. So assume that the journey is scheduled on June 15th. So the competition is on. Assume that the competition is on June 17th. And so the flight departure is at 11 a.m. June 15th. Can you able to see my screen? Is it clear?
Yes, sir.
Right. So the flight departure is at 11 o'clock, 11 a.m. kundi flight, June 15th ki. Dattatreya, who are your teammates? ఎవరెవరు వెళ్తున్నారు ఫ్లైట్ లో? దత్తాత్రేయ ప్లస్
Pawan sir.
ఓన్లీ పవన్, రైట్. సో దత్తాత్రేయ అండ్ ఇస్ పవన్. Who is
Aditya.
Aditya, right? So దత్తాత్రేయ, పవన్ అండ్ ఆదిత్య 3 members వెళ్తున్నారు, రైట్. సో దే ఆర్ స్టార్టింగ్ ఫ్రమ్ నూజివీడు క్యాంపస్, నూజివీడు క్యాంపస్ నుండి. యాజ్ దే ఆర్ హ్యావింగ్ ఎ లాట్ ఆఫ్ మనీ విత్ దెమ్, ప్రైజ్ మనీ అదంతా చాలా వచ్చేసింది దత్తాత్రేయ దగ్గర. సో దే హ్యావ్ బుక్డ్ వన్ ఇన్నోవా వెహికల్ బుక్ చేశారు. ఇన్నోవా వెహికల్. సో నూజివీడు టు హైదరాబాద్ ఎయిర్పోర్ట్, right? Noziri to Hyderabad airport. Now how much time does it takes from Noziri to Hyderabad airport? Pandalsa, approximately how many hours? How many
5 to
hours?
6.
Right, 5 to 6 hours. Flight time enti 11 a.m. Right. So journey time is, assume that 6 hours. 6 hours anukunnam. Now what happened is, so Dattatreya, so they have started at 4 a.m. start here. 4 a.m. start here. Now in between, as they have got so much of money with them, restaurant దగ్గర ఆగారు, which is located at సూర్యాపేటలో పెద్ద రెస్టారెంట్ ఉంటుంది హైవే మీద. Which restaurant is it? రెస్టారెంట్ పేరేంటి? హైవే మీద ఉంటుంది. ఎనీవన్ knows that? Right. So వివేరాలో ఆగారు అనుకుందాం. Now here they have spent 1 hour, and they have reached the Hyderabad airport at 11 a.m. Now Dattatreya thought that I am having flight tickets, I am from IIIT Nuzivedu, our HOD sir is Irfan sir, so I am going for Innovate FPGA. I am representing India. I am the only team which is representing India in Innovate FPGA. So they will stop flight for me. Flight నా కోసం ఆపేస్తారు అని చెప్పేసి అనుకుంటాడు. అలా అనుకొని ఎయిర్పోర్ట్కి 11 o'clock రీచ్ అవుతాడు. బట్ అన్ఫార్చునేట్లీ దత్తాత్రేయ couldn't get into the airport. Flight లో ఎక్కలేడు. Even though the flight departure time is 11, flight departure time is 11 a.m. Dattatreya and his team reached the airport at 11 a.m. But still he couldn't get into the flight. ఎక్కలేడు. He couldn't get into the flight. So ultimately what happened? So దత్తాత్రేయ దగ్గర ఫ్లైట్ టికెట్స్ ఉన్నాయి. దత్తాత్రేయ నూజివీడ్ నుంచి ఉన్నాడు. వాళ్ళ హెచ్ఓడి సార్ ఇర్ఫాన్ సార్ ఇండియా నుంచి ఓన్లీ దత్తాత్రేయ మాత్రమే రిప్రజెంట్ చేస్తున్నాడు. బట్ ఈవెన్ దెన్, సో దత్తాత్రేయ did not went for Innovate FPGA finals competition, which is held at California, US. Right. Now, what do you understand from this? దత్తాత్రేయ ఏమర్థమైంది నీకు? What do you understood? What you have understood?
ఎఫ్ఎస్ఎంస్ లో కూడా
ఎఫ్ఎస్ఎం కాదు, ఇక్కడ నీకు ఏమర్థమైంది? ఈ ప్రాబ్లంలో ఏమర్థమైంది?
అందరికీ వెళ్ళాలి.
రైట్, తొందరగా వెళ్ళాలంటే ఎప్పుడు వెళ్ళాలి? సో airport people, what they will be saying is, please arrive before 45 minutes for international departures అంటారు. 2 hours కూడా అంటారు, 45 minutes is sufficient for international departures. Can you listen me clearly?
Yes, sir.
Right, please arrive before 45 minutes for international departure, such that so you can complete the process of check-in, బోర్డింగ్ పాస్ తీసుకోవడం, అలాంటివన్నీ కూడా కంప్లీట్ చేస్తారని చెప్పేసి. సో యూ షుడ్ బి అట్లీస్ట్ బిఫోర్ 45 minutes ముందు వచ్చి ఉండాలి అని చెప్పేసి అంటారు. సో వెన్ ఈస్ ఫ్లైట్ షెడ్యూల్? ఫ్లైట్ ఎప్పుడు షెడ్యూల్ అయింది?
11 సార్.
సో ఫ్లైట్ ఈస్ షెడ్యూల్డ్ ఎట్ 11 AM. రైట్. నౌ వాట్ దే హ్యావ్ టోల్డ్, ఎయిర్పోర్ట్ వాళ్ళు ఎప్పుడు చెప్పారు ఎప్పుడు రావాలి అని చెప్పేసి? అట్లీస్ట్ 10:15 కి రీచ్ అవ్వాలి. Now journey time is, what is the journey time? 6-hour journey time. So when you are supposed to start, ఎప్పుడు స్టార్ట్ అవ్వాలి న్యూజిలాండ్ నుంచి? 3:15. Right, so if you start at 3:15, then only you can catch the flight. So if you are starting at 4 AM, even though you are having flight tickets, even though you are HODs, Irfan sir, even though you are from Tudlite University, you cannot travel to California. So this is what the setup time means. We shall discuss about the setup time in the next class, not today, in today's class. Now setup time says that even though the circuit is proper, inputs are correct, everything is properly constructed, everything is properly designed, and everything is properly made, but if the signal, availability of the signal, ఇక్కడ సెటప్ టైం అంటాడు, టీ సెటప్ అంటాడు. ఈ సెటప్ క్లాక్ బిఫోర్ ద అరైవల్ ఆఫ్ దిస్ పాజిటివ్ ఎడ్జ్, బిఫోర్ ద అరైవల్ ఆఫ్ పాజిటివ్ ఎడ్జ్, బిఫోర్ ద ఫ్లైట్ డిపార్చర్ 11 AM. 11 AM కి ముందు 45 minutes, before 45 minutes you are supposed to come and you are supposed to be available in the airport itself. This also says the same. The signal is to be available before some time instance, 2 nanoseconds or 3 nanoseconds, before the appearance of, before the arrival of the clock edge. Clock edge ki mundu availability undali. Input clock signal, which may be D input or T input or J input, K input, whatever it may be. So the inputs must be available before the arrival of the positive edge. దాని ముందు సెటప్ టైం అని చెప్పేసి అంటాం. సో యు ఆర్ సపోజ్ టు టేక్ దిస్ సెటప్ టైం ఆల్సో ఇన్ టు కన్సిడరేషన్. అదే కదా ఇక్కడ చేసింది. యూ హ్యావ్ added the travel time is added. Travel time is added plus 45 minutes, the condition which is kept by the airport authorities, that is also added. You రెండు యాడ్ చేసుకున్నారు. Suppose if you are calculating only the travel time, 6 hours మాత్రమే క్యాల్కులేట్ చేస్తారు అనుకోండి, then you cannot get into the flight. So the same thing here also. So you are supposed to add this, the propagation delay plus the setup time. These two are to be added. This is not today's discussion. This we'll be discussing only in the next class. Okay, wait. Right, can you see this PDF which is made available here?
Yes, sir.
Right. So this. So an ASM block ASM block will consist of a state box, will consist of a state box plus a state box plus a decision box, a decision box plus a conditional output box, conditional output box, and interconnection of such ASM blocks, interconnection of ASM blocks is nothing but ASM chart. This is what the definition, or this is what it will be described in the textbooks. So ASM chart is nothing but interconnection of ASM blocks. So what is an ASM block? ASM block is nothing but, so I mean a representation which will have an interconnection of a state box plus decision blocks plus conditional box. ఇవి three ఉంటాయి, and this is compulsory, and these two are optional. These two are optional. It is not mandatory. ఇవి రెండు mandatory కాదు. These two are optional. They may or may not be available. Now this is represented in this way. This is taken from a textbook. So this is the representation of a state box. Now the input line will be there here, and there will be an output line. Now towards the left side, see, this representation is fixed. We are not supposed to change this particular representation. ఈ రిప్రజెంటేషన్ అనేది ఐ మీన్ మనం చేంజ్ చేయడానికి లేదు. స్టాండర్డ్ రిప్రజెంటేషన్ విచ్ ఇస్ ఆల్రెడీ గివెన్. So state name is to be written on this side. So here it is state name. So state name, it can be S0, it can be S1, it can be S2, or else it can be, so my name, or else it can be the name of the Dattatreya, or else it can be name of the EC department, or else it can be the initialize, or it can be the reset state. So anything. ఎప్పుడు స్టేట్ నేమ్స్ అంటే S0, S1, S2నే ఉండాలి అని ఏం లేదు. The state name can be anything. State name can be anything. So here the state name is written as initialize. So the code is nothing but the binary representation of that particular state. So binary representation of that particular state. So if there are, so 2 states or 3 states or 4 states, so depending upon that, so we'll be choosing, we'll be taking so depending upon that, so we will be fixing the number of bits that are required for representation of code. Then after that, so if it is a more machine, outputs will be available here itself. If it is a more machine, so we all know that. So the state machines are of two types. One is melee machine and the other is more machine. If it is a more machine, output of the more machine will be written in this particular, so state box itself, state box itself. So this is an example. Then after that, so the decision box, the input of the decision box will be coming from the output of a state box. It's state box ఎక్కడైతే ఉందో, so దీని output వచ్చేసి దీనికి కనెక్ట్ అయిపోతుంది. State box output gets connected to the input of a decision box, and from this, so there will be multiple outputs. So true case, false case, ఇలా రెండు ఉంటాయి. So there will be true case and also there will be false case. So the decision box. Then, so from the output of this particular decision box, we can connect it to the conditional output box. conditional output box. So outputs are operations, and from here conditional output నుంచి నెక్స్ట్ వచ్చేసి నెక్స్ట్ స్టేట్ వస్తుంది. So these three operations takes place in a single clock cycle. So this is state, then decision, then after that conditional output. So these three takes place in a single clock cycle itself, or single clock cycle lo అయిపోతాయి. A small example is so taken here. So where CS is nothing but a chip select, LD is nothing but parallel load, LD is parallel load, SR, this is shift register, SR is the shift register, or set register values, set register value, right? This is small example itself. Now this example is to illustrate or is to explain the functioning of, or the explain how this algorithm state machines will be drawn. So here now this is nothing but a state box. This is a state box where S naught is nothing but the state name, and here they are representing with 4 bits. So it is up to them వాళ్ళు 4 bits ఎందుకు తీసుకున్నారో. This is only a small example. This is not complete. Complete కాదు. So here 1, 2, 3. Even though there are 3 states, they are representing with 4 bits. Right. Now after that, CS chip select. If CS is equal to 0, if CS is equal to 0, if chip select is equal to 0, chip select is equal to 0, then the set register value to zeros. Set register value to 0. This is the output, conditional output. Set register value to 0. Then after that, now when you will be entering into S1 during the same cycle or the next clock cycle. Suppose if this is happening in the first clock cycle. So suppose if we are entering into the S0 in the first clock cycle లో S0 enter అయ్యాము. Now please tell me when we will be entering into S1 state. S1 state కి ఎప్పుడు ఎంటర్ అవుతాం? When we will enter into S1 state, right? Only after second clock pulse. Only after second clock pulse we will be entering into S1 state. Now please tell me when we are going to get this particular set register value 0. So SR is equal to 0 ఎప్పుడు అయిపోతుంది?
First clock cycle.
Same in the first clock cycle itself. So they will be doing it with the help of the asynchronous inputs values. What are asynchronous inputs in register? Asynchronous inputs in the register lo,
Clear set.
right? Clear value, reset value ఉంటాయి. So those. So with the help of the clear, we can make all the outputs of the register to 0. చేయొచ్చు కదా with the help of the clear 1, clear 0 అని చేసి చేయొచ్చు కదా. So here with the help of asynchronous inputs, they will be doing this, right? Next, on the other side, if chip select value is equal to 1 and if load value is equal to 0, if load value is equal to 0, so it is said that so go to the same state, repeat S naught లోనే ఉండండి అని చెప్పేసి చెప్తుంది. If SR is equal to AA, so AA here is represented with in hexadecimal format. What is the value of AA in decimal format? What is the value of AA in decimal format? AA is represented in hexadecimal format. What is the value of AA in decimal format? Anyone from the group?
So 16 power 10 plus.
16? What is the value of AA? AA is present in hexadecimal value than the decimal value. 1? 170 of base 10, right? So if load value is equal to 1, so set register value to 170 set అవుతుంది. Now in which clock cycle this will happen? CS 1 అయిపోయింది, load 1 అయిపోయింది, SR is equal to 1 అయిపోయింది. Now will it happen in the second clock cycle or not? S naught is happening in the first clock cycle. And after that, if CS is equal to 1, load is equal to 1. Now when do we get this particular value? SR is equal to 170 అనేది ఎప్పుడు వస్తుంది? In the first clock cycle or second clock? Second clock లో వస్తుందా? Why it is so? అలా ఎలా వస్తుంది? SR is equal to 170. First clock లో వస్తుంది. We will be getting only in the first clock. They will be doing with the help of asynchronous inputs. Now, how they will be doing is their own problem. అది ఎలా చేస్తాం అనేది ఇప్పుడు మనం డెరైవ్ చేయము, asynchronous inputs ని ఎలా యూజ్ చేస్తాడని చెప్పేసి. But with the help of the asynchronous inputs only, so they will be setting the value of the register to 170. This happens only in the first clock cycle. First clock cycle ని అవుతుంది. And after the next clock cycle, after the positive edge, it entering into the value S2. S2 లోకి వెళ్ళిపోతుంది. Is it clear? Is it clear? Is this example clear? We are not going to implement this particular example. This example is only to understand. So the decision box, conditional output box, the state box, clock cycle. అది అర్థం చేసుకోవడానికి మాత్రమే. We are not going to implement this particular example. Is it clear?
Yes, sir.
Right. So now, this is a representation of a state diagram. This is a representation in state diagram. In state diagram, what will be there? What are the components? A circle will be there. And from this circle, suppose it's a reset అయితే, if this is S0, if input is equal to 1, output is equal to 0, S1, if input is equal to 0, output may be 0 or 1, S2. And we have another state diagram, S0 by 0. In this way, if this is 1, S1 by 0, this is 0, S2 by 0. So this is nothing but melee machine antam. This is more machine. This is present state. This is next state. This is next state. This is present state. This is next state. And this is next state. If this is considered as a present state, you will be getting some other state as next state. See, the same thing is mentioned here. M0 stands for more output. ME stands for melee output. In the circle, we will be writing the state name. M0 is equal to value. More output అయితే ఇక్కడే output రాస్తాం. More output value ఇక్కడే రాస్తాం. Then after that, the logic expression. So input is equal to X is equal to 1 by Z is equal to 1. ఇలా రాయొచ్చు. In some textbooks, they will be representing simply as X by Z or X bar by Z. X by Z bar రాస్తారు. Now what is the meaning of this X by Z bar అంటే meaning ఏంటి? X is equal to 1, Z is equal to 0 is the meaning. 1 by 0 అన్నట్టు. In some textbooks, they will be writing the logic expression also. You need not confuse with this. Always 1 or 0 నే ఉండాల్సిన అవసరం లేదు. In some textbooks, logic expression may also be written. Logic expression కూడా తీసుకోవచ్చు. Or else x1 x2 by z, x1 bar x2 by z bar, x1 x2 bar by z. In this way also, here it says that x1 is equal to 1, x2 is equal to 1 by z is equal to 1. That meaning. To other state. This state diagram. Algorithm ASM block. This is the ASM block. ASM block. So ASM block లో ఏమంటాడు? We'll have a state box. State box లో state entry ఉంటుంది. Here it is state name. Here we can write code also. m0 is equal to value, that is more output value, more output value. Then after that, a decision box, don't get confused here, sir. So then ki number of sites, so this is 1 2 3 4 5 6 ఉన్నాయి, బట్ మీరు డ్రా చేసిన డెసిషన్ బాక్స్కి ఓన్లీ 1 2 3 4 ఉన్నాయి. Is this another box? No, it is not the another box, both are the same. So either this or this, both are same, decision box is same. So this representation is from this textbook, Pong Pichu FPGA prototyping using Verilog. దాంట్లో ఇది రిప్రజెంటేషన్ యూజ్ చేశాడు డెసిషన్ బాక్స్కి, అండ్ దిస్ రిప్రజెంటేషన్ ఈజ్ యూజ్డ్ ఇన్ సో స్టీఫెన్ బ్రౌన్ plus most of the textbooks. Then after that, if it is a melee machine, then we will be having this particular conditional output box. If it is a more machine, do we have this particular conditional output box? More machine అయితే ఉంటుందా? More machine అయితే ఏమి ఉండదు. And whenever this is written in this way, this here it indicates that the value is equal to 0. ఇక్కడ అక్కడ ఏం లేదు అంటే స్ట్రైట్ అవే ఇలా వెళ్తుంది అంటే లైన్, అది 0 అని చెప్పేసి దాని మీనింగ్. రైట్, is it clear? I hope it is clear for everyone. Right, now everyone try to do this problem. P7 try చేయండి. Problem 7, try this. Try this. Obtain the ASM chart for the following state transitions. Obtain the ASM chart for the following state transitions. If x is equal to 0, control goes from state T1 to state T2. If x is equal to 1, generate the conditional operation and go from T1 to T2. If x is equal to 1, so and so, so and so. So try it. Right, solution for A. First, I will be taking a state T1. State T1. This is the state entry. Now, how many states are present here? So T1 and T2 states. So this I will represent with 0. Then after that, if x is equal to 0, now here we have a variable x is equal to 0 on this side, x is equal to 1 on this side. If x is equal to 0, control goes from state T1 to state T2. State T1 to state T2. This is T2 state. T1. This is T2 state represented with 1. If x is equal to 1, generate the conditional operation. It means that generate the conditional output. So the conditional output is generated here with the help of some variable z is equal to y is equal to, and go from T1 to T2. Now we are supposed to go from T1 to T2. Right. Is it okay? Okay. రైట్ ఇక లూప్ ఫినిష్ అవ్వాలని ఏం లేదు. దెర్ ఈస్ నో కనెక్షన్ ఫ్రమ్ T2 టు T1. సార్ T2 నుంచి మళ్ళీ T1కి వెళ్ళలేదు కదా అంటే ఇట్ ఈస్ నాట్ గివెన్ ఇన్ ద ప్రాబ్లమ్ స్టేట్మెంట్. In problem statement it is only mentioned, I mean these are the only sequences that are mentioned. So T1 is one state. If x is equal to 0, it goes from T1 to T2. If x is equal to 1, generate the conditional operation, in the sense generate the conditional output and go from T1 to T2. So it is done. Now the problem B. Problem B states that
Sir, initial and final condition అని hello sir.
yes,
Sir, initial గా T కి బ్లాక్ మ్యాన్ 0 పెట్టలేదు సార్. T2 కి అవుట్పుట్ 1 పెట్టారు.
your voice is not clear. Can you repeat your question? Hello. Can you repeat your question? Hello. So the second problem, if x is equal to 1, control goes from the second problem. T1 state entry. So T1 right side corner or actually right, sorry, left side or left side top. So both are acceptable. This is my T1. This is my coding. If x is equal to 1, if x is equal to 1, control goes from T1 to T2 and then to T3. If x is equal to 1, control goes from T1 to T2, T1 to T2, and then it goes to T3. Then it goes to T3. Then it goes to T3. If x is equal to 0, control goes from T1 to T3. If x is equal to 0, control goes from T1 to T3 directly. Three states are present. So this is 0, 0, this is 0, 1, this is 1, 0. Is it clear for everyone?
Yes, sir.
That someone is expressing some doubt. A and B are two different problems here. A is one particular problem and B is another problem. No different problems have it. Right, see this. Now try this particular problem. Draw the ASM chart for the following state transitions. Start from initial transition T1. If xy is equal to 0, 0, go to T2. Xy is equal to 0, 1, go to T3. If xy is equal to 1, 0, go to T1. Otherwise, go to T3. So you will be given 2 minutes. 4:15 p.m. Answer చెప్పండి. Draw the ASM chart for the following state transitions starting from the initial state T1. XY00 either T2 కెళ్ళాలి 01 T3 10 is T1 otherwise go to T3. If you are done, you may send a message. You may post a message here. Jyotsna is done. Dattatreya is done. Anjaneyulu is done. Gautam is done. The GVS Bindu is done. Vijay Lakshmi, Shiva Devana, Mansud Sheikh, Sharanya, Dharmavati, Dimple, Sohail, Aishwarya, Rakesh Verma, Rajeshwari, so Madhavi. Okay, fine. Right. So let me draw it. If there are any mistakes, you may correct me in between. Initial status T1 is my initial state. Now here there are three states, so let me denote it with the help of 0 0. Now x is one of the input. Now depending upon the x, we cannot determine what is the next state. Here we have y also. We have y also. We have y also. Now if this is 0 and this is 1 on this side, x is equal to 0, and if y is also 0, x is equal to 0, y is equal to 0, what will be the next state? Go to T2. X is equal to 0, y is equal to 0, next state is T2. X is equal to 0, y is equal to 1, go to T3. X is equal to 0, y is equal to 1, it is T3. It is T3. Now x is equal to 1, y is equal to 0, x is equal to 1, y is equal to 0, go to T1. If x is equal to 1, otherwise go to T3. Otherwise in the sense y will be equal to 1. Now is it okay? Is it right?
Sir, XY blocks ని మెర్జ్ చేయొచ్చు.
XY బ్లాక్స్ ని మెర్జ్ చేసేసి అంటే ఎలా రాస్తావా?
అంటే ఫోర్
ఎలా
ఫోర్
XY
ట్రాన్సిషన్స్
రాసేసి
తీసుకోవచ్చు సార్.
ఎలా తీసుకుంటావు? Now will you take in this way? Xy is equal to 0 0, xy is equal to 0 1, xy is equal to 1 0 1 1 ఇలా తీసుకుంటావా?
అలా తీసుకోవచ్చా సార్?
No, no, అది లేదు. No, it is not mentioned. It may be logically correct, but that particular notation is not mentioned. Logically correct అవ్వచ్చేమో, it is not mentioned in any of the textbooks. ఇలానే మెన్షన్ చేశారు. ఓన్లీ వన్ వేరియబుల్, వన్ ఇన్పుట్ మాత్రమే తీసుకున్నారు ఇక్కడ.
ఇన్పుట్ చాలా ఎక్కువ ఉన్నా కూడా అలాగే రాయాలి.
I have gone through I have gone to 2 3 textbooks. So far I have seen only one variable. If there is any other alternative representation, I will let you know. So till then you follow this. Present అయితే ఈ నోటేషన్ చూసాము, ఓన్లీ వన్ వేరియబుల్ మాత్రం రిప్రజెంట్ చేశారు, మల్టిపుల్ వేరియబుల్స్ ఏం మెన్షన్ చేయట్లేదు అలా. Right. So as of now, this is the standard notation that is to be followed. If there are any other notations, I'll let you know. Right. Right. Can you answer this? Can you do this? So 420. 5 minutes will be given for you. 425. I need an answer for this. Draw the ASM chart. ASM chart for sequence detector to detect the sequences 4 ones or 4 zeros. Overlapping is not permitted, and it has to output a 1 when the sequence is detected. Whenever the sequence is 4 ones, output must be equal to 1. Whenever the sequence is 4 zeros, output must be equal to 1, and overlapping is not permitted. Overlapping is not permitted. Please draw the ASM chart for this particular problem. Now, if it is done, you may send a message. You may post a message. So Yashwant is done. Dattatreya is done. Jyotsna is done. Samba Shiva is done. Rakesh Verma, Aishwarya Naidu, Durga Praveen, Gautam, Sohail, Bindu, Vijay Lakshmi, Sharanya, Vinod Kumar, Uma Maheshwari, Mansud Sheikh, Shiva Devana. Okay, good. Now let me draw this. You may compare your answers. Right, we'll start with one particular state. Let that state be S naught. Then after that, now how many input variables will be there here? Two input variables or one input variable?
One.
Only one single bit will be coming. X value. Now if X value is equal to 0, if X value is equal to 0, it enters into a state. Let this be S1. And if X value is equal to 1, if X is equal to 1, let it enter into another state. Let it be S2. S naught and S2. Right. Then after this, S naught, again the value of X.
So S1.
Right. Okay. It's S1. So this must be S1. Okay. So across this, X is equal to 0, X is equal to 1, both are defined. So now across S1, we are supposed to define the outputs for 0 and 1. Now whenever it is 0, what will happen? The next state will be
S3.
S3. Next state will be S3. Now if it is 1, what will happen?
Reset.
Reset avala.
Yes, yes2 kelal sir.
Yes2. It goes to S2. It need not reset. So reset happens only when output is equal to 1 case. Overlapping is not permitted in the sense what we have done is, so I have shared a PDF also for you. So ఎప్పుడైతే output 1 అవుతుందో, so then it will be reset. That is, it enters into the initial state. Or else it may use any of the available states which are mostly useful అవుతాయో ఆ states కి వెళ్ళిపోతుంది. Right. Now how shall we indicate this? ఎలా indicate చేయాలి? This is 0. Is it okay? Any confusions here? In order to avoid overlapping of the lines, I have taken in this way. Overlappings అనేవి అవాయిడ్ చేయండి. ఒక లైన్ ఇలా డ్రా చేసి then another line in this way, then another line in this way, and another line in this way. ఇలా డ్రా చేయకండి. Try to avoid so this overlapping of the lines. Right. Then after that, and now here S1 is a state. S1 is a state which has detected a single zero. S3 is a state which has detected a sequence of two zeros. Two zeros ని డిటెక్ట్ చేసేస్తుంది S3 అనేది. Right now. Then after S2, what will happen? After S2, if x is equal to 0, what will happen? If x is equal to 1, what will happen?
Next state.
Next state, right, perfect. So S4, let it be S4. Now if it is 0, if it is 0, now let me draw here. If x is equal to 0, it enters into S1. Right. Now here also the same thing is happening. S2 is a state which has a remembered one. See, in ASM we are not supposed to draw this. Red color aitha unnayo avi raayakandi. Only for understanding purpose I am marking here. These are not supposed to be written here. So this is for 1-1. 1-1 is completed. Whenever we are in S4, it is nothing but the detection of 1-1 state. 1-1 detect అయిపోయింది and దాని meaning వస్తుంది. Right after S3, again the value of x, if it is 0, if it is 0, the next state is S5. If it is 1, what will happen? If it is 1, what will happen? Right, so it enters into S2. Right. We may mark in this way. We may connect to this. This is also accepted. A line connect చేస్తే సరిపోతుంది. Right. Then after this, x again. If this is equal to 0, what will happen? If it is equal to 1, it goes to S2. If it is equal to 0, what will happen?
Output generate అయ్యి reset.
Right, generation of conditional output, perfect. Z is equal to 1, and since this is a non-overlapping circuit, overlapping is not allowed here, so we are supposed to move to the initial state. We are supposed to move to the initial state, which is S0. S0. Now similarly here also the same thing. After S4, if x is equal to 1, it enters into S6. If x is equal to 0, if x is equal to 0, S1 state. After S6, if x is equal to 1, what will happen? Generation of output.
Generate.
Right, perfect. And a reset to initial state. Reset to initial state. Initial state. Or else you may draw in this way also. Clear ga undali sir ante. Right. Is it clear for everyone? Now here what I have told you is, so this particular process, so from here to here, so from this state to this state, it is going to take one clock cycle, one clock cycle, this operation. So that is S2 state generate అవ్వడం, then after that x value, if x is equal to 1, ఇక్కడ వరకు కూడా మన క్లాక్ సైకిల్ అవుతుంది. దెన్ ద నెక్స్ట్ స్టేట్ S4 జనరేట్స్ ఇన్ ద నెక్స్ట్ క్లాక్ సైకిల్. S4 అనేది మళ్ళీ నెక్స్ట్ క్లాక్ సైకిల్లో జనరేట్ అవుతుంది. S4 will be generated in the next clock cycle. So here output will be generated in this particular clock cycle itself. Output will be generated in the same clock cycle. Right. Now see this. So this is the problem. This is yesterday also we have discussed one such problem. So develop an ASM chart for a controllable waveform generator, for a controllable waveform generator that will output any one of the four waveforms as shown. That will output any one of the four waveforms. The four waveforms are this. So this is 1, this is 2, this is 3, this is 4. Four waveforms ఉన్నాయి. దీంట్లో ఏదో ఒకటి మాత్రం అవుట్పుట్ రావాలి అని చెప్పేసి అంటున్నాడు. అండ్ హీ హాస్ ఆల్సో గివెన్ దిస్, whenever x1 x2 is equal to 0 0, I am supposed to get this particular signal, which may be p, this may be q, this may be r, and this may be s. Now you please draw a state diagram for this, sorry, ASM chart for this. Draw an ASM chart for this. I'll give you 5 minutes again. 4:40 p.m. Now it is 4:36. First, check the time period of each waveform. Maximum time period ఏముందో చూడండి, and the maximum time period will be equal to the maximum number of states in this particular problem. Are you online? Can you hear me?
Yes, sir.
Yes, sir.
T53 and 70. So Shiva Devana has completed the problem. So Anjanelu has done it. Yashwant has done it. Only two students. Only two students. A similar kind of problem, I mean, related as we have done in yesterday. So let me take an initial state as S naught. The first is, if I am taking this as one time period t, one clock time period, so the time period of the signal p is, what is the time period of signal p? 2t. The time period of signal q is how much? 4t.
40.
Right, perfect. The time period of signal r is also 4t. And the time period of, what is the time period of signal s?
3 t.
Right, 3t, perfect. 3t, okay. So 40 is the maximum time period, maximum repetition. So four states. The first is, let me take S naught state. Now if I check this, in S naught state, all the outputs are ones. So here the output is equal to 1 here, here output is 1. So it is 1, it is 1. Now with respect to what we are speaking, with reference to the first clock cycle, with reference to first clock cycle, output is equal to 1. With reference to the first clock cycle, this clock, ఈ clock గురించి మాట్లాడుతున్నాం. With reference to the first clock cycle, my output is equal to 1 always, and hence I will place this in the z itself. I need not compare again. Malli x is equal to 1, y x1 is equal to 0, x2 is equal to 0. Now, all those considerations need not be taken. Irrespective of all those, during the first clock cycle, the z value is always 1. So that is marked. Then after that, so then it entered into the next state, S1. Next state కి enter అయిపోయింది S1 లో. Now see this, during the second clock cycle, and the first clock cycle అయిపోయింది, clock cycle A has completed. Now during the second clock cycle, we are entering into state S1. In state S1, the outputs are different for different signals. So అన్నిటికి zero, I mean, it, we are not having a zero signal or one signal for all the four, zero output or a one output for all the four signals. Zero output, one output లేదు, four signals, and hence we are supposed to take the x1 and x2 into consideration over here. Now let me take x1 here. So x1, whenever x1 is equal to 0 or x1 is equal to 1. Now if x1 is equal to 0, do you have any doubts? Can you hear me? Right, you can hear me, right? So when x1 is equal to 0, when x1 is equal to 0, these two signals. If x1 is equal to 1, these two signals will be coming into the picture. Now x1 is equal to 0, x2 signal, x2 signal, x2 signal may be 0 or x2 signal may be 1. x2 signal is 0, x2 signal is 1. Now whenever x2 signal is equal to 0, what is happening here? x2 signal 0 అయినప్పుడు ఏమవుతుంది? So here output is equal to 0. So I'll mark here the outputs also. This is 0, this is 1, this is 0, and this is 0. This is during the second clock cycle. Second clock cycle B. We have named the second clock cycle as clock cycle B. So in second clock cycle, these are my outputs. So whenever x1 is equal to 0 and x2 is equal to 0, so my output is equal to 0. And what will be my next state? Do I need to move to S2 or loop repeat అయిపోతుంది ఇక్కడే?
Yes, not sir.
Right. So loop repeat here itself. Loop is going to get repeated. So and hence draw a line towards the state is not. x2 is equal to 0. This is done. So one signal has been generated. So this signal is generated. Then if x2 is equal to 1, what is happening? x2 is equal to 1, what is happening? So output is equal to 1, right? A conditional output box. Z is equal to 1 or simply Z. So Z is equal to 1, and then we are moving on to the next state. So we are moving on to the next state. Let the state name of the state be S3. S3 is the name of the state, right? So this part is done. Now whenever x1 is equal to 1 and x2 values
Sir, x2 మీద డిపెండ్ అవ్వచ్చు సార్, అంటే 0 వేసుకోవచ్చు.
x2 depend అవ్వట్లేదా? Right. So see here. So what he is saying is, ever answer చెప్పింది? Who has given the answer? Right, Veerababu. Perfect. So what Veerababu is saying is, sir, so if x2 is equal to 0, my answer is 0. If x2 is equal to 1, then also my answer is 0. So you need not verify the condition. మళ్ళీ మీరు x2 చెక్ చేయాల్సిన అవసరం లేదు. It is waste of time, and hence, so we are supposed to move to the next state or loop repeat అవ్వాలా?
నెక్స్ట్ స్టేట్.
Next.
Right, we are supposed to move to the next state, S3. Now in S3, we are supposed to check what is happening in S3. Now in S3, say this. So the first condition 0 0 is eliminated. 0 0 0 1 1 0 1 1. So 0 0 is eliminated. Why? Because 0 0 condition is getting repeated for every 2 clock cycles. Antena? For every 2 clock cycles ki repeat అయిపోతుంది. So S0 first clock cycle, S1 second clock cycle. So 0 0 signal has been generated. P అనే signal అయిపోయింది. Now we are left out with the generation of Q, R and S signals. So Q, R and S signals. Q, R and S signals. Now let me take here x1. So x1 is equal to 0, and these are x2 is x1 is equal to 1. So x1 is equal to 0 and x1 is equal to 1. Now whenever x1 is equal to 1, what is my output? Whenever x1 is equal to 1, x1 is sorry, whenever x1 is equal to 0, what is my output?
One sir.
One.
sir.
Right. Let me indicate here. Now here this is equal to 1. So this is already repeated. We will not draw this. This is getting repeated. So this is getting repeated here. So here it is equal to 1. Here this is equal to 0. and this is equal to 0. This is happening during the third clock pulse. The third clock pulse is named as C here. Tn named as M. Right. Now whenever x1 is equal to 0, now do I need to check the condition of x2 మళ్ళీ చెక్ చేయాలా? మళ్ళీ ఇక్కడ x2 ప్లేస్ చేయాలా? Is it required?
Not.
Only one condition is there here. Check this. So whenever x1 is equal to 0, so I am getting only one condition for x2 is equal to 1 మాత్రమే వస్తుంది. But whenever x1 is equal to 1, I am getting two conditions for x2 is equal to 0, x2 is equal to 1. So here x1 is equal to 0, only one condition. మళ్ళీ మీరు x2 అనేది చెక్ చేయాల్సిన అవసరం లేదు. So hence we will be removing this particular part. Now tell me what is the output here?
One, sir.
Right, 1. So z is equal to 1. Now do I need to move to the next loop
Yes, sir. Next state calls.
or initial state వెళ్ళిపోవాలా? Next state.
Next state.
Next
Next
state.
state.
Right, perfect. So next state, we are moving on to the next state. Yes, 4. Right. Now towards this side, x2. If x2 is equal to 0, what will happen? If x2 is equal to 1, what will happen? Right, so 0 and 0. So x2 is equal to 0, output is 0, x2 is equal to 1, output is equal to 1. So irrespective of the value of x2, irrespective of the value of x2,
సార్ కానీ సార్ అంటే ఒకదాన్ని రీసెట్ చేయాలి కదా సార్ ఇప్పుడు.
right? So but the problem is, so the signal R is of repeating for 4 clock cycles ki repeat అవుతుంది, and signal S is repeating for 3 clock cycle, which is depending upon the value of x2, which is depending upon the value of x2, and hence we are supposed to consider this particular block. Now tell me, now which is repeating here whenever x2 is equal to 1. This is 0, right? Whenever x2 is equal to 1, it gets repeated. అంతే కదా?
Yes, sir.
Whenever x2 is equal to 1, it is going to get repeated. Repeat 2. Yes, not. Okay, done. So we have completed with this also. We have completed with this. Now this is in repeat state. This is also in repeat state. Now we are supposed to generate only this. So here it is 0 and here it is 0. Now we are left out with the conditions 0 1 condition and 1 0 condition. These conditions are left out. Conditions. Now see, whenever it is 0 1, x1 x2 0 1, what is my output? Output ఏమవుతుంది చెప్పండి?
0.
So this
Zero,
is
sir.
4th clock. So my output is 0. Now whenever it is 1 0, what is my output?
0.
Then also it is 0. Then after this, after this only repetition only, right? After this it is only repetition. రెండు 4 clock cycles ఉన్నాయి signals. So both are of 4 clock signals. So straight away I'll be repeating this particular loop. Straight away I'll be repeating this particular loop. Suppose if it is of one it is of 4 clock cycles and the another one is of 5 clock cycles, then we are supposed to take x1 x2 into consideration. అప్పుడు మనకు డిపెండ్ అవుతుంది, x1 అయితే 4 clock cycles, x2 అయితే 5 clock cycles అని చెప్పేసి. But here, so both are getting repeated for 4 clock cycles only, and hence I'll be drawing a line from the output of S4 state to the input of the S0 state. So is it clear?
సార్ ఒక వేరియబుల్ అయినా కన్సిడరేషన్లోకి తీసుకోవాలి కదా సార్?
Then ఎందుకు తీసుకోవాలి?
అంటే మరి 1 1 అయితే సార్ ఒక x1 x2 మనం 2 కండిషన్స్ చూసాం కదా సార్, 1 0కి 0 1కి.
రిమైనింగ్ అన్ని రిపీటెడ్ కదా, ఆల్రెడీ రిపీట్ అయిపోతున్నాయి కదా. సో దిస్ ఈజ్ ఆల్రెడీ ఇన్ రిపీట్ ఫేస్, దిస్ ఈజ్ ఆల్రెడీ ఇన్ రిపీట్ ఫేస్. For 0 0 it is already getting repeated. ఇది ఇంకా రిపీట్ అయిపోతుంది. For this also it is getting repeated. S signal is only for 3 clock cycles. For every 3 clock cycles S signal అనేది రిపీట్ అయిపోతుంది. And P signal is getting repeated for every 2 clock cycles. So అవి ఇంకా రావు, కన్సిడరేషన్లోకి రావు. Now we are supposed to generate only QR మాత్రమే జనరేట్ చేయాలి. QR మాత్రమే జనరేట్ చేయాలి. Or else you do one thing. Now for this particular diagram, draw the waveforms. Draw the waveforms with respect to clock. Then you will be understanding more. You'll get more clarity. ఇది తీసుకొని ఒకసారి మళ్ళీ డ్రా చేయండి, వేవ్ ఫార్మ్స్ డ్రా చేయండి. దెన్ యూ విల్ బి అండర్స్టాండింగ్ ద కాన్సెప్ట్స్ ఇన్ ఎ మోర్ క్లియర్ వే. Is it clear?
Yes, sir.
Now who asked that question?
Gautam, sir.
Gautam, once you do this reverse process,
Okay,
then
sir.
you will be understanding. Already repeat అయిపోతుంది క్లాక్స్ అన్ని కూడా. 1 చెప్పింది అయితే ఉందో ఆల్రెడీ రిపీట్ అయిపోతుంది అది. రైట్. Okay, so now I want you to do this problems. I'll be sharing this document. So the problem P1, so it is the one which is discussed in yesterday's class. So P2 is done now. P3 is also done now. P4, draw an ASM chart and state diagram for the circuit shown below. I want you to draw the ASM chart as well as the state diagram, both. So, but the first is, so we are not having the relation so between the present states and the next states and the outputs. So first is present state. The first is present state. Input values. Present state is Q1, Q0. Input values. What are input values here? X is my input. Next state values are Q1 plus and Q0 plus. Now output is indicated with Z. Anyone is having doubts on this? Present state Q1, Q0 ఎందుకు అవుతుంది? Why present state is not X అని చెప్పేసి ఎవరికైనా డౌట్స్ ఉన్నాయా? Any doubts on this? Hello?
No, sir.
Right, I hope you shouldn't have any doubts, right? So CP is nothing but a clock pulse. Now, is this a synchronous circuit or asynchronous circuit?
Synchronous.
Synchronous.
Right, this is a synchronous circuit. Now the initial values of the Q1 and Q0, assume it as zeros. Initial value of Q1 is equal to 0 and the Q0 is also 0. Both the values are zeros. And hence, if the present state is 0 0, if X is equal to 0, can you tell me the value of Q1 plus and Q0 plus immediately?
0
What?
1
0
0
1 1 0 0 1 0 1 is one answer, 1 0 is another answer. Next, any other answers? Any other answers?
1 0 sir 1 0.
Right, so 1 0 is one answer. Any other answers? Any other answers?
One.
1 1 is one answer. Any other answers? Right, let us check what is happening here. Now output of the combinational circuit, output of AND gate. So this is 0 here and this is 0 here. X input we have considered it as 0, so this will be 0 initial right. The output of AND gate, output of OR gate రావడానికి మనకు clock cycle కావాలా? Do we require any clock cycle? Do we require any
No, sir.
clock pulse? No, right?
No, sir.
Asynchronous outputs. This will be equal to 0. This will be equal to 0. Whenever this is 0 and this is 0, what will be the output of XNOR gate?
1.
1.
Right, this is 1. Now what is Q1 bar value here? Q1 is
1.
equal to 0. This is 1. Right, this is 1. Now apply the clock pulse here. Apply the clock pulse. Force this particular flip-flop and force this particular flip-flop. Negative edge, not the positive edge. These are negative edge here. Apply the clock pulse here. Apply the negative pulse. So whenever you are applying the negative edge here, so both the flip-flops are going to respond simultaneously at the same time. Rendu respond అవుతాయి. Now this value will become. Now what will be the value of Q1 now?
1, sir.
1.
What will be the value of Q0?
1.
1. 1.
1.
1, sir.
1 1 simultaneously. Okay, so generate just side. So this is equal to 1 and this is equal to 1. So whenever one of the input for OR gate is 1, so obviously Z value will be equal to 1. So in this way analysis is to be done. Analysis is to be done in this way. Do not get confused with this particular 1 0. I will confuse avakandi. Suppose if it is 0 0, if X is equal to 1, then what will happen?
0 1. 0 1.
0, 1, sir.
Oh,
0, 1, sir.
okay. Let
1
me check.
0.
Let me check once. X is equal to 1. X is equal to 1 here. Q1 value is 0. Q0 value is equal to 0. Q1 bar will become 1 and hence 1 will be available here. X is equal to 1. Now what will be the value of Z initially? Z will be 1.
1, sir.
Z will be 1. That is before the application of the clock signal 1 ఉంది. తర్వాత clock signal అయినప్పుడు ఏమవుతుందో చూడాలి. And this is equal to 0 and hence this is 0. Now what will be the value of D1 here?
0 sir.
D1
అంటే
value
1 ఉంది
ఎంత?
కదా.
0 and 1. This is equal to 0. Now apply the clock signal, negative edge. Apply the negative edge here. What will be the value of Q1?
1. 0 sir.
0. What will be the value of Q0 plus?
1, sir.
What will be the value of Z?
Z కూడా 1.
1,
1, right, perfect. So this is the answer. So in this way you are supposed to draw this particular complete state diagram, and after that once the state diagram is done you may draw the state transition table. State transition table may be drawn. State transition table ఎలా draw చేస్తారు? So this is my present state 0 0 state 0 0 state. Then after that, so the value of x is equal to 0. Next state value Z value, x is equal to 1. Next state value Z value. In that way it should be done. So you please do this. You'll be understanding things. Now draw the ASM chart for these particular things. So this will be simple. D flip flop, JK flip flop, T flip flop. Now consider next state as output. So output em undadu D flip flops ki, JK flip flop ki, T flip flop ki. Consider next state value aitha undo, the Q plus aitha undo, consider it as output value. Z is equal to Q plus అని తీసుకోండి. Z is equal to Q of n plus 1 అని తీసుకోండి. So P6 is done. P7 is done. P9, draw an ASM chart for this. And don't go for state diagram again here. State diagram draw cheyakandi. Straight away draw ASM chart for this particular state diagram. Right, so we are done with today's class. So I'll be sharing this particular PDF. So spend some time and do this particular exercises. Any doubts?